Hi, my name is Jonathan Wilson. Today we're going to pull the curtain back on search engines to help you get a top-level overview on how they work. A search engine can take on many different forms. Most users are already very familiar with some popular search engines like Google, Bing, or Yahoo. Search engines are notoriously complicated, so my goal is to use a human frame to better explain how they function. Let's start with a metaphor. Suppose you're in a new city, in this case Austin, Texas. You're unfamiliar with your surroundings on a casual Saturday stroll. You're just walking through the city, taking things in, and having an exciting time exploring the city with no real agenda. On your right, you notice a restaurant, Franklin's Barbecue, that seems to be really popular. The place is packed with people, and as you get closer, you overhear lots of people gushing about how delicious the food is. You get a little bit closer, and then you smell that wonderful scent of barbecue. You can see the food looks so well prepared, and you think to yourself, wow, this looks really good. But again, you're not really hungry. You're just exploring the city, checking things out, and so you keep on walking. A little further down the street, you happen upon another barbecue place. You're not really sure from the sign if it's Big's Barbecue, Igsby Barbecue, or something else. Either way, the place looks really dead. There's no crowd, and no one's talking about the restaurant. You get a little bit closer to the barbecue spot and peek in the window to get a look at the food. You see this. It's black, burnt, smells bad, and the texture looks almost painful. As you keep walking down the street, your brain is recording what you just saw. The two restaurants, with their vastly different quality signals, carry different weight in your mind as you travel on. Suddenly, you run into an old friend. Total coincidence. During your chit-chat, your friend asks you, "Where's a killer local place that we can get some BBQ?" Immediately, you start thinking about the two restaurants you saw earlier. You think about a bunch of different factors like wait time, quality, speed, smell, and 100 other variables. In less than a second, you provide your answer and recommend one of the places you just saw. Now think for a moment. Which food place would you recommend to your friend? Franklin's Barbecue with the big line and great looking food, or barren Big's Barbecue with the burnt chicken? If you're like most people, you'd recommend Franklin's Barbecue. So let's walk through what just happened here. We observed the world around us using our senses. We stored those observations in our brains. We got a question from another person, and we quickly thought through all those factors that were stored in our brain. And in the end, we quickly respond with, "I'd recommend Franklin's Barbecue." For most of us, this process is fairly straightforward. We make hundreds of decisions every day based on the same method. It's what makes us human. That same process we went through, that's exactly how search engines work. Let's break down that first step and relate it to how a search engine works. If you recall from the example, as humans, we walk around the city using our feet to get from one spot to the next. Rather than using feet, search engines employ crawlers to move through the internet by jumping from link to link. When I say link, I mean that blue underlined text that you see when you go to a website. The crawler, robot, or bot, as they're sometimes referred to, can only travel by jumping to these links. Similarly, whereas when we were walking, we used our senses to understand the world around us, search engines jump from link to link, copy text, and save it to their index. There are also limitations to what humans or search engines can observe. Just like humans can observe things like air or molecule that aren't perceptible to our senses, search engines can't understand much more than text. Therefore, whereas air is invisible to us, non-text elements like video are essentially invisible for the search engines. Remember, search engines can only read text, so that information from above looks like this. A search engine can only read text. After following a link to a new website, the crawler lands on the site and starts saving the text information on the website. As a review, search engines perceive using bots that mainly consume text that move from jumping from link to link across the World Wide Web. The next step, indexing, is the process where a search engine takes the information it was able to perceive and puts it into an index. As humans, we showed in our example, we store that information in our brain. That's where we keep our judgments about Big's B barbecue and Franklin's barbecue. Size-wise, the human brain is about 2.5 petabytes, which equals 2.5 million gigs. That's 2.5 million of those little 1 gigabyte thumb drives that make up your human brain. That's a lot of storage. In comparison, Google's index is 100 petabytes. That's about the size of 19 human brains. Now that's enormous. We've established that Google's index, or their brain storage, is huge, but now let's talk through what's being stored inside that index. First, the index holds content, like the code behind a website, just like how we as humans might store the content of a particular restaurant. Though this content is stored in the index, the search engine is able to categorize that information by classifying it based on different rules. For instance, the index might hold information about the following. Where was this page or site published? What's on the page? What's the quality of the content on the page? Who wrote it? How well is the person who wrote it known? Beyond the actual website itself, the index will also store information about the website. If you remember from our real life example, we remembered that Franklin's barbecue had lots of people waiting in line to eat. This wasn't the actual content of the restaurant's food, but it provided a good indicator that if many people were willing to wait outside, the content was probably pretty good. In that sense, the crowd acts like an endorsement. In the same way, search engines look at links to the website, similar to the way we look at people waiting outside of a restaurant. Those endorsements can be a good proxy for quality. That's why it's important to make sure a website has links or endorsement pointing to it. Take this screenshot from the Wall Street Journal. That hyperlink text pointing to Franklin's Barbecue's website is the equivalent of having someone physically standing outside of Franklin's saying, "I'm from the Wall Street Journal and I endorse this restaurant." Links matter and help show that a website is legitimate. Similarly, that link from the Washington Post pointing to Franklin's Barbecue acts like an actual endorsement. This time, the search engine sees this as saying, "The Washington Post endorses Franklin's Barbecue." There are many more links pointing to Franklin's Barbecue from a number of relevant quality web pages. Each of these links or endorsements sends signals to the search engines that Franklin's Barbecue is legit. This is the online equivalent of having a bustling line outside of a physical restaurant. The search engine will also store user data. They're tracking the emails you send, where you've been, what apps you use, your social media, and other content to get a better understanding of who you are so it can provide strong recommendations. In summary, the search engine crawls a huge amount of information and stores it inside that giant index. Inside that index, you'll find on-site information like content and off-site information like links, as well as user data. So we walked through how a search engine crawls a website and how they store that crawled information inside the index. Let's move now to the query. So if you remember from our example, our real life query came in the form of a question from a friend. For search engines, the query is often typed into the search box, and even more commonly, the query is simply just spoken into the phone. Whatever the format, let's take a look at this example query to get a better understanding about how our brain processes the query. Even though the phrase, "Where's the killer local place that we can get some barbecue," seems straightforward to us, it's actually really complicated. When we say where, we're showing that we want an answer of a location. When we say killer, we don't literally mean something that's going to end our lives. We just mean good. And good is also relative. When we hear good, we generally assume that it means good-looking, healthy, well-cooked food, but really that's an assumption. Someone could think good means well done to the point of being burnt. Local is also relative because it depends on where you are. Since you're in Austin, local means somewhere in this city's vicinity. Lastly, BBQ is slang for barbecue. So even in that short sentence, there's a lot of slang, implied knowledge, and expectations from the person asking the questions. Our brains can quickly decode these complex sentences to understand what the asker is looking for. In the same way, search engines employ semantic search, a process of decoding queries to better understand intent and context. A good search engine, like you, can quickly decode requests to understand what the user is really trying to find out. Once we've understood the query and its intent, the next part is the thinking, or in computer terms, the algorithm. As humans, we're constantly running different algorithms in our head when we make decisions. In our example earlier, we took into account the smell, quality, and other factors to make a good food recommendations. Search engines do the same thing. They review the information stored in the index, compare it to the query, and start analyzing. The algorithm is basically a recipe that sorts through billions of data points to give you the best answer to your query. For both humans and search engines, these algorithms run seemingly instantaneous despite being super complex. It's important to know that algorithms can change over time. Just as your definition of a fun activity has evolved from when you were a baby to now, search engines evolve their algorithms to evolve with the times. For instance, mobile phone users eclipsed desktop users a few years back, as shown in this chart. As a result, in this evolution with how users are accessing the internet, Google had to evolve. Knowing that more than half of queries were on a mobile device meant that users were expecting mobile pages. So last year, Google introduced a change to its algorithm to give more importance to mobile pages. This is just one of hundreds of algorithmic updates Google and the other search engines roll out on a continuous basis to ensure that they're keeping up with users' evolving needs. In summation, the algorithm is analogous to thinking. That thought process or algorithm is the secret sauce that differentiates Bing from Yahoo or from Google. At its core, though, all good search engine algorithms should be aimed at understanding and providing answers to users' needs. We're on the last step, the SERPs, or Search Engine Results page. If you recall from earlier, we made the final decision to recommend Franklin's Barbecue after weighing multiple information points stored in our brains. Since the question was asked to us verbally, we respond verbally. Again, our answer matched the user's expectations. Search engines work in a similar way because they want to provide answers in a format that matches user expectations. Let's walk through some examples. I typed the query, audience falling asleep. In this case, the search engine is giving me recent articles about the topic and images of people falling asleep. Based on my query, they're thinking that I'm looking for timely information or an image, so that's what they provided. In contrast, if I search for car accident lawyer near me, the search engine is going to interpret that as having local intent. So the search engine results page is going to feature a map and a listing with an address. Again, here we see the SERPs match my intention. Let's do one final review of what we discussed today. As humans, we observe the world around us with our senses walking through the city. Search engines crawl web pages moving from link to link. As humans, we stored those observations in our brains. A search engine stores information in its index. We get a question from a person. A search engine gets a query from a user. We quickly think through everything in our brain. A search engine uses an algorithm to make decisions based on what's in the index. Finally, after thinking, we respond verbally for our answers. A search engine responds through the search engine results page. In subsequent presentations, we'll dive deeper on these different topics, but I hope this helped to provide a top-level overview on how search engines function. I'm Jonathan Wilson, and thanks for watching.